This is question 1 from the miscellaneous practice sheet on eWC, and we're using Pythagoras theorem here and also our basic definitions of circular measure for trig. So the question goes like this: if we've got tan of alpha is 4/3 and cos of beta is equal to 12/13, and we're told that they're both acute angles, which means this, then we're asked to work out exact values for some trig things. So we're going to start right back with the basics, which is what are my definitions, and I'll work with something in the first quadrant here. So this line has length r and vertical distance of y, horizontal distance of x. Remember, my basic definitions go like this: that the cosine of the angle made by the positive direction of the x-axis in that line r, that's defined as x over r. Sine theta is defined as y over r, and tan of theta is equal to y over x. Right, so it's well worth having this picture in your head whenever you get an exact values problem like this one here. And it's going to work to draw this out whether we're over here or down here, which is what's going to happen in question 2 on the practice sheet. Okay, so similar ideas. So now we're going to take a look at what we can say about the Pythagoras relationships for each of these. So I'm going to start by just drawing the two things separately. So this is alpha, and tan alpha is equal to 4/3. And because of our definition, that means that y is 4 and x is 3. So r must go like this. From Pythagoras, we know this, and in this case we know already that we've got a 3, 4, 5 triangle, but we'll work it out. So r is 5. Now just notice that r is always going to be a positive number, but remember x and y will be either negative or positive, especially if we are round here. Everything's easy here because x and y are both positive. So now that I've got the third side of that triangle, I can work out sine of alpha, which is y over r. That will be 4/5, and cos of alpha will be 3/5. We can do the same thing for the second picture here. So we're told that, I'll do it in green, cos of beta is 12/13. So the 12 is the x and the 13 is the r. So this is 12, this is 13, and this must be 5, right? So 12 squared plus y squared equals 13 squared. Y squared is 25 and y is 5. But you should recognise already that this is the other famous Pythagorean triple, which is 5, 12, 13. This one up here is 3, 4, 5. Okay, so now finally we're just about ready to get on with our problem. We've got sine of alpha, cos of beta. We should work out sine of beta and tan of beta. I'll do a new slide to keep it a bit. So sine of beta is equal to y over r. So that's 5/13, and tan of beta is equal to y over x, which is 5/12. Once you've done a few of these, you'll do that step much more quickly. Now we're ready to work out some things using identities. So part A, tan of 2 alpha is equal to 2 tan alpha over 1 minus tan squared alpha. So nothing hard about that one. Tan of alpha, so that's 2 times 4/3 over 1 minus 4/3 squared. So that equals 8/3 divided by 1 minus 16/9. We'll keep going on the next slide. So that gives us 8/3 divided by -7/9. 8/3 times 9 over -7, which is just -24/7. Cos of 2 alpha, well, we've got quite a few choices for how we do this one, because we've got, of course, the 3 versions of the double angle for cos. So I'll use this one. So that's going to be 2 times 3/5 squared minus 1. Right, so what we've got here is we've started with a 3, 4, 5. We've been given one ratio, and now we can work out the other two. So we've got 2 times 9/25 minus 1. Works out to be 18/25 minus 1, which is -7/25. Cosec of 2 beta is equal to 1 over sine of 2 beta. We can expand that using our double angle. And we're back to our building blocks of the sine and the cos of beta. That's equal to 1 over 2 times 5/13 times 12/13, which equals 1 over 120 over 169, which is another way to write this, 169 over 120. Right, last one. Cos of alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. We know what each of these is, we just substitute. So 3/5 times 12/13 plus 4/5 times 5/13. We already have a common denominator, it's 65. So we get 36 plus 20 over 65, which is 56 over 65. Right, I'll do the harder question later on. It's question 2, where you've got angles over here and angles down here, but it's the same idea.